and welcome. My name is Philippe Flichy. I am a digital transformation advisor, and I have been working on large IT integration during all my career. Today, we will explore how to harmonize the integration of people, processes, systems, and data within a work environment. A company operation is based on people interacting together. They rely on processes, a series of steps undertaken to achieve a desired outcome. These processes rely on information systems, which are interrelated components working together to collect, process, store, and disseminate information to support decision-making, coordination, control, analysis, and visualization in an organization. Data is becoming the new company asset. The next leap in performance, safety, and environmental improvements will be digital. The digital economy is demanding dynamic, decentralized, data-driven, automated, and self-learning workloads that must be integrated and orchestrated to deliver business solutions in the new world we're entering. Digital transformation is driving changes that include decentralized workloads spread across applications and data over multiple clouds, on-premise systems, data centers, mobile and stationary edges. The challenge we are facing is that data is isolated in many different repositories and applications, often proprietary. Access across multiple clouds and on-premise, as well as data centers, is very complicated, not mentioning how departments often ferociously protect them. Data on its own represents many challenges. Volume, to start with. Data has always been big, only getting bigger. The original big data was actually the Library of Alexandria, which construction started 285 BC and contained the combined experience and learnings of 10 centuries. In 1944, the concern was that American universities and their libraries were doubling in size every 16 years. And that number of published volume would outpace the ability to physically store them. Nowadays, every year, we are doubling the size of data created since the beginning of humanity has been writing. Yes, that is exponential. Velocity, one of several aspects of the speed of data. One should consider not only how fast data is being generated, it is also how fast it is becoming stale or obsolete, and how fast we need to analyze it to make it more meaningful. Variety relates to the type of sources. Many unstructured, such as email, blogs, logs, documents, which can be used to answer many verification questions. Imagine that today, 80% of data in the world is unstructured, and at first glance does not show any indication of relationships. Yet, AI can extract very meaningful correlations from them. Variability is the consistency over time. Variability has a strong impact on believability. Veracity is the authenticity and credibility of the data. Conformity with truth or facts. Data must be truthful, or the decision we make will not be valuable. Can it be trusted? Visualization is the art of presenting data in a relevant fashion for large data sets to be consumable. Last but not least, value is the ultimate goal. Collected and curated data ought to create value for the company by driving efficiency, accuracy, and predictability. Fortunately, with more data also comes more computing power and various flavor of artificial intelligence, which are enabling new solutions which were not previously possible to implement. A recent Stanford University research demonstrated how in 2 years, artificial intelligence is being trained 4,800 times faster. The digital economy competition puts high value on real-time engagements, decisions, integration to support a mixture of analytical and transactional workloads. Digital demands to reshape existing data assets not built for hybrid, cloud, big data, and mobile environment. We need a new tool, integration and orchestration services capable of preserving existing applications and data repositories while adding new ones. If our present toolbox doesn't do the trick, we need to invent a new one. One which can leverage technical tools such as AI and machine learning based systems to ease the connection of these disparate sources of information across a company and even beyond to facilitate inter-enterprise processes. They must identify the existing structure and protocols to assemble them in a coherent system. An integration platform as a service called iPaaS should offer a unified platform that addresses customers' integration needs, including process, applications, data, and external partners to facilitate business-to-business integration. All users, including developers, architects, IT operators, managers, citizen integrators, business analysts, and of course, data engineers, must be able to interact with this platform through their respective but integrated user experience. The platform should support DevOps and makes the integration efficient while driving continuous integration and delivery. An iPaaS orchestrates business process and integration workflow across on-premise, hybrid, multi-cloud applications, data sources, and partners. It typically supports multiple integration patterns, such as on-premise to cloud migration, real-time data integration, business-to-business data hub application and integration, and hybrid master data management. It manages data security and governance, harvesting knowledge across existing successful implementations, and know how data structure can augment the user experience with automation and guidance as part of the orchestrations. The guidance includes delivering recommendations for process logic, data mapping, exception handling, and deployment models. The integration and orchestration capabilities of an iPaaS must be built and modified using self-service, no-code, low-code, and experts development services. This puts application, process, data, and business-to-business integration, as well as APIs development and management into the hands of multiple personas, including IT developers and integration specialists, as well as line of business technologists and end users. Most importantly, these teams should be able to deliver these capabilities using their current skill sets. Visibility, governance, and control across data, applications, and orchestration process workflows, as well as API, are required so that self-service doesn't get out of hand. In terms of visibility, the iPaaS should assist developers with intelligent creation, development, management of cloud and on-premise APIs to extend the life of legacy systems, but also preserve years of investment in business functions that otherwise would need to be re-implemented. It needs to provide cloud-based monitoring and management of data, API, and integration operations, as well as visibility into orchestration execution and exceptions, and also allow administrators to manage operations from cloud-connected devices, including smartphones and tablets. But at the end of the day, humans have to trust each other's. First, to produce the right understanding of how this algorithm are processing and creating those associations. Only with the integration of various interactions, of various subject matter experts and data specialists, will we be able to mine our data more profoundly. The more you will try to mine your data, the more you will find innovative ways to extract insight from it. Be the first to reach out on the other side of the aisle to build trusting relations. Everything starts with humans. The aim of data trust is to give people and organizations confidence when enabling access to data in ways that provide them with value in return, directly or indirectly. Do we have a reason to doubt about the data we have? If not, we will tend to trust the data. Trustworthiness is the degree of confidence one has that the system performs as expected, such as consistency, congruity, reliability, and integrity. This involves various facets of data management. First, the source of the data. Can we believe it? Does it make sense from a physics, range, data type perspective, whatever is important for that type of data? Does the source has a good reputation? Is it official? Is it neutral, known to be objective? Is that source usually reliable? Second, the handling of the data. This starts with the source. Can it be verified? What about traceability? Were there some possible alteration and transcoding, manual or automated? Could it be possible that alteration took place intentionally or not? A mistake by someone? A modification by an expert or an application? Some criminal activities? Do we know the configuration parameters of the sensor and the associated softwares used to capture and process the data? To establish trust, we should record as many as possible of these trustworthiness parameters into metadata. Metadata is a set of data that describes and gives information about other data. You may want to use them to also get information about a sensor position, a maintenance book, a calibration table, to understand the drift of a sensor over time, for instance. Conversion from analog to digital values is another aspect you'd want to track, such as sampling rates used. For some data, timestamps can be complicated to reconcile in order to have a proper understanding of what happened at a precise instant between different sensors. AI bots can learn from metadata. But if the data is not properly validated via a trusted, verifiable process and properly localized and curated, the data is not going to be trustworthy. And you're only going to get garbage in, garbage out. A 2016 Veritas study found that 48% of corporate data is tagged or classified, of which only 15% is business critical and 3% redundant, obsolete, or trivial. This leaves more than half, 52% of company data dark with an unidentified value. You know that file that you leave on the hard drive somewhere for your spreadsheet that no one else but you can make sense of? Yeah, that one. Tools scrolling through heaps of data find not only correlations, but also duplicates and help versionizing them. As the platform is learning, the cost of homogenizing the data and the interface to manipulate it will go down. So we can spend some time on optimizing our activities and processes rather than collating and corroborating data sets, as most of us are doing today. How do we evolve from automation to hyper-automation, as Gartner has coined it? Until recently, automation has typically focused on using technology to execute rule-based, repeatable tasks that require considerable manual efforts. Automating this task saves valuable time for employees and increases productivity, process speeds, and accuracy. Hyperautomation builds on that business value. It begins with the foundation of process automation technologies and expands their capabilities with artificial intelligence, the ability to discover, prioritize, and track automations, IDs in one place, process mining, analytics, and much more. This means that more types of processes can be automated and optimized. Data orchestration is the automation of data-driven processes from end to end, including preparing data, making decisions based on that data, taking action based on those decisions. It is a process that often spans across many different systems, organization, and types of data. Without a consolidated data platform, data is siloed and thus incomplete, old, and inaccurate. This limits a business ability to get a complete picture of all factors which influence key decisions required to realize business initiatives. A single multi-tenant portal on which each user, given its technical abilities, can create its own tools, given their domain expertise. So be clear. Each individual can create its own tools given the level of technology savviness they have. This is what Keross is proposing with their Icon orchestration platform, which is a tool to develop workflows for any type of operations. It is already largely adopted in the automotive and construction industries. The root of digital transformation journey can be found in the sudden abundance of data and the means to process it. Humans are very good at evaluating and choosing between few alternatives. We can, more or less, concentrate on up to 7 indices at once and make decisions upon those data points. On the opposite, computers can correlate many times more data points at a split of a second, but for now, have not gotten the level of judgment call a human expert can exhibit. This opportunity is due mostly to the advance in computing power. Artificial intelligence is not new, but the algorithms required need massive computing power, which are more and more available nowadays. I encourage you, if you want to know more about Keross, to just contact me on this information you have over there. You can send me an email at dx@philippeflichy.com or visit philippeflichy.com, and I will redirect you with Keross. Thank you very much for your time.